Austin, hey, I'm gonna unmute you. You have a question or a comment. Let me I have an extra component, Austin. All right, Austin, let me unmute you. Austin, hey, how's it going?
Um, Good. Were we supposed to get those, or were they supposed to come in the kit?
The hardware?
Yeah, the bolts and stuff.
They were supposed to come in a kit.
Yeah, I didn't get those.
You didn't get the ultrasonic sensor or the hardware as well?
No, I didn't.
Okay, thank you.
No problem.
Nothing else came in that package? You didn't throw that away, did you?
No, the package. I still have it. I took everything out of it. The two whatever they are, the things with
Servos?
the servos. Yeah, and
Okay,
the robot thing. It came all pushed out and everything like that. And then the Arduino kit.
okay,
But I didn't get that or the hardware of those. That's all that came though. If there's more stuff, I didn't
okay.
get that either.
And then the Arduino kit, the battery kit.
And then the battery cable come with the Arduino kit, correct?
Yeah, the battery cable came with the Arduino.
All right.
That's what was missing.
Well, thank you, Austin. Stay on the line after class, and we'll get that all squared away. And I'm
Okay.
gonna go again and mute you and lower your hand. All right. Everybody else should have everything so far. Uh, so let me thank you for that. I appreciate that. This should have been done on the first day of when I took over, but well, we need to take a step back. Sometimes that happens. So let me continue on and make sure your Pi is up and running. If it's not, make sure your Pi is up and running, or the computer that you're going to use for the Arduino. Because today we're going to finish the ultrasonic sensor, and I believe that's probably all we're going to get to today. We're going to save the servos for next class, and but we may talk about some servos later on this class. But I don't know if we're going to get into that. So again, let's continue on with that. And today we're going to code the Arduino. I think we already did that, so the code should be already there. Going to recap, of course, to start to remind you and to get warm up our brains. Again, we warm up for multiple reasons. One is we want to get our synapses firing in that direction. It's kind of like warming up before a race or a match. I used to wrestle and run. I used to do a lot of the sports, so it's kind of warming up your body. This is like warming up your brain, and you also want to do that if this is advice for school or anything like that. If you're presenting or have a project or a test, you want to warm up and start to think about the process at least a half hour beforehand. So you're not in shock when it comes down to taking the test or anything. It's kind of like starting up your car in the morning and going from 0 to 60, just pulling out the driveway, which is not good for your car. It's not good for your mind either. So let's continue on. You should have your ultrasonic sensor again. Sensor actuator. They call it a sensor, but it is an actuator as well. And we're going to talk about physically hooking that up. We talked about the coding last week, and we'll review the coding and make sure we'll debug anything that you have. And then we'll go into actually physically hooking it up and some experiments that you can do. Questions like how can I trick the sensor? Uh, how can I for instance, they had to play this game in the Korean War with radar in World War II. And how do I trick radar? And how do I stealth it? So these are some valid questions that you can think about. How do I come at this sensor without it knowing it? So which is kind of tricky, but it's also fun to kind of play those games as well. Uh, and I think Jacob, I'm going to pause it. Jacob has a question. I'm going to unmute you, Jacob. Jacob.
Actually, there are a lot of ways you can get around radar and such. If you've ever looked into that, if you've ever read a book about that, there's a lot of ways to get around it if you look into it.
Absolutely. Uh, Multiple ways. Thank you, Jacob. I appreciate that. Uh, Multiple ways to get around radar, and there's going to be multiple ways of getting around this ultrasonic sensor. So that's very important. And I'm going to lower your hand, Jacob. And then, if we get to it, I would love to talk about servos and the little motor that can. some coding and some physical hookups, possibly some of the introductions, but let's focus on the ultrasonic sensor. So this is what you need for today's lesson. Again, we reviewed it last week, but let me show, when you're done gathering these, we should have an ultrasonic sensor, an Arduino, a half breadboard, and 4 wires. Now let's kind of stick with the color coding of red being hot and black being ground. Let me see a raise of hands when you have all of these. And remember, your Pi is supposed to be up and running. So let me see a raise of hand who has all of these so I can continue on. All right, so about 60% of you, a little over 60% have these at hand, which is good. I'm gonna lower your hands, and we can continue on. So once you get that, we're gonna start to, this is just to get you thinking about that and collecting all of the stuff we need for today. But of course, some review, some questions for you guys to answer, rather than me sitting here and talking to you all. You're gonna talk to other people. So, what part of their Arduino is C? Again, Corey has his hand up. Of course, awesome, Corey. Let me unmute you first. Corey, how you doing?
Analog pins support they're a range, a spectrum, as opposed to just 1, 0. They're quantum, not digital bits.
Analog, yes. That's correct. And he went even further than I would have right now. But yes, let to know that these are the analog pins. Corey, thank you so much. Awesome. Awesome. So let's continue on, of course, with the review. Now, name 3 differences on how we normally set these constraints in a sketch. Now, I'm going to lower everybody's hands first and name one at a time. So just name one first, and then we can go this. Now, remember, we define these variables a different way than we normally define them. So, show a raise of hands how we normally define the differences. One of the differences between this, how we defined it in C, and how we defined it in Sketch. Again, let me see a raise of hand. Anna, you were the first. So, Anne, hi, how are you?
Good.
Good. Nick, can you name one of the differences?
Yeah, there's no semicolon.
No semicolon. Awesome, Anne. Thank you so much. I'm going to unmute you. Anne's perfectly right. No semicolon. So anyone else want to take a stab? Yeechin, I'm going to unmute you. Yeechin, hi, how are you?
Good, and that is another difference. There's no int.
No int. Yes, perfect. Thank you. Mute. Thank you, Yeechin. That's awesome. No int or no double or no float. We just number define. And then we solve that. So again, what is another difference? Can anyone take another? So for you to take a look at what we defined before and what we have on the screen now, you would see one other difference. Anyone want to raise their hand at this? One other difference. We have a semicolon and we don't define an int as we've been defining it previously. No one else? Jeremiah. Awesome, Jeremiah. Jeremiah, how are you?
Good.
Good. What is the third one?
There's no equal sign.
No equal sign. Thank you, Jeremiah. Yes, Jeremiah is absolutely correct. There is no equal sign in here relative to what we were talking about, or relative to what we are talking about. And this is a way to define things. We can define things in multiple ways in Sketch. So, all right. Now this is, I'm gonna lower everybody's hands, and we can start fresh. Now this one I did get incorrect last time, so I want to make sure that you know How many microseconds are in 1 second? So I think I saw Yeechen's hand first. Yeechen, how you doing again?
Good.
Yeechen. Good. All right.
Yeah. 1 million microseconds. 1 sec is in 1 second.
Perfect. Yeechen. Awesome. 1 million microseconds. Again, I did get that wrong last time, so I want to make sure you guys understand that it is 1 million microseconds, and there are 1,000 microseconds in 1 millisecond. Again, I did get it wrong last time, and when you get something wrong, this is an important lesson for all of you. Admit to it. Admit it to it, and that's where you learn, and that's where you can get corrected. You don't want to speak unintelligently or go down a wrong path just because you misspoke. So let's continue on with our review. What does this symbol represent? Let me have a raise of hands of what symbol does this represent? Oh, Ari, I saw you. Ari, hi, how are you?
Good.
Good.
That would be the light detector, right?
Light detector. Yes, also known as a photoresistor. Thank you. Or light LDR, light detecting resistor. Thank you, Ari. Thank you. This is we went over this a week or two ago. I forget now. A week ago, and that is, as you notice, that is a resistor because it's like I said, the Japanese language or Chinese language. As I was learning Japanese, there were symbols built upon symbols, not like the English language. That you have a symbol for resistor. That means it's some sort of a resistor, and then it's a light arrows going into it show light, and a circle around it means it's enclosed. So again, I'm going to lower all your hands and continue on. What is pin mode? Again, some of the same questions pop up. So Corey, I'm going to unmute you. Corey, do you have an answer for what is pin mode?
Last I checked, it sets the mode of the pin to telling you to do something or reading the value.
Awesome. Yes. Great job, Corey. Great job. So again, it does tell you the pin number to go to, and then it says what it needs to do. Is it an input or is it an output? Output usually are actuators, and inputs are sensors. So nice job, Corey. Nice job. All right, let us start. So let's start continuing and start your Arduino. So let me show a raise of hands when you have your Arduino started. Not what I'm going to do the same thing, and I'm going to start my Arduino just to have in the background. So when you are done and it is up and running, let me see a raise of hands. Let me see a raise of hands when it meaning the Arduino sketch is running. Sometimes on a Raspberry Pi it may take a little bit long. That is perfectly fine. Once I get a little over 60%, we'll continue on. I got 60% now. All right. All right. Well, let's continue on. And nice job. I'm going to lower everybody's hands. And we're going to write the program and write the program here. We should have, if you haven't done so already and saved it from last week, please open it now. So again, open the sketch we provided last week. So if you're having trouble viewing it, it starts like this. And once you have the sketch up and running, just as a view, so it should look, the beginning looks like this. Raise your hand if you have the sketch already into. What I'm going to do now is I'm going to collect all of this and put this into the sketch. So again, go back to this. So again, this should be, you should have saved this as something last week, called it ultrasonic sensor or something like that. So again, raise your hand if you, not just this, but also this as well. So again, if you can read this, here's what it should look like. I'll put that on the side here. So again, raise your hand. I'm going to pause for a little bit. Raise your hand to let me know that you have all of this copied, pasted, or up and running. This is the same code we went over last week. So again, I'm going to mute you until I have a little bit more people that look at the code. So I'm going to mute you until I have at least 60% that have this code in their sketch. All right, so I have 56%. Make sure that everyone has it. 63, perfect. All right, now I continue on. Again, I'm going to leave this sketch up here as we go on and continue on with our. So now we don't need to so much look at the sketch as we do need to look at the hookup. Now we are at, this is where we stopped last week. So it took us 35 minutes to get here, but we're still good. So physical hookup, take your black wire and put it, place it in the ground and somewhere in a column. That's on, try to look at it from the opposite, from the closest one. So the farthest column on, one of the farthest columns on the half breadboard. Again, make sure that you have, don't put it towards a side, put it towards the center, but make sure it's on the farthest column. So in this case, it would be the most bottom. So you don't want to be in these columns. You want to make sure it's on the bottom columns. That'll make sense in a little bit how I have it hooked up. So again, I'm gonna lower your hands and continue on. So again, you want to make sure, and all of this will be compounded on each other. So again, what you want to do, this is important now, you want to put the yellow wire or some other color besides black and red. And you want to make sure that that connects to pin 13 up on your Arduino. And that needs to be next to, on the left from your black wire. Again, on your left. And if you've done this, raise your hand. All right, I have some questions that popped up. We're going to pause for a second. Brandon asked, for the hardware before all the screws, would the wood glue, screwdriver, etc. be included in the kit? Yes, the wood glue is not included in the kit. The screwdriver is not included in the kit. The tools, what we call tools, are not included in the kit. Those are usually kind of ubiquitous in a household. So some maybe the you should have it in your household, meaning ubiquitous, meaning throughout households they should have them. Ari, you don't have LED pin anywhere in your code. Well, make sure you put the LED pin in your code if it needs be. If you look at it, there shouldn't be an LED pin in your code, so that's good. And Austin, should I not run the program after we wire it because I have no output for the power? No, on this one, I'm not understanding your question, and I'm gonna go to Austin. And Austin, I'm gonna unmute you, and so you can ask me directly. Austin, hi, how are you?
Good. What I meant was, should I not run the program after we wire everything up because I don't have the ultrasonic sensor, and I wanted to know if like it would cause problem because there's no output to send the power to.
No, you could yeah, you can try to run the program. What it does is it downloads it and makes sure everything's working, although it's not going to work on the serial monitor. That's a great question. And yeah, keep hooking up to make sure you kind of run through the process of it, so you're familiar with this at any rate. Thanks, Austin. So, Quarry, can I use the ground on the other side of the Arduino? Yes, you can use the ground on the other side of the Arduino. Great question. Corey asked, can I use the ground on the other side of Arduino? Ground is ground. Ground is ground. No matter what it is, it's still ground. So, so yes, you are correct. You could put it on the other side of it. So I'm going to continue on. Now this is a crisscross. So notice the white goes to pin 12 and on the other side of the yellow. So if I'm going from left to right, it starts out as white, yellow, black, and make sure you have that. So I'm going to lower all your hands, and when you're done with this setup, again, it's going to crisscross. On mine, the white over top of the yellow. So again, raise your hands once this is correctly put in, so I get a sense of everything. So again, make sure once this is done, I have a raise of hands, and make sure they are crisscross. So like the 12 pin is on, it's from left to right. It goes white, yellow, black, or color A, color B, and then black. I want you to keep the ground black on this diagram. So once that's set up, let me tell me that you know or you have it hooked up, and raise your hand so you can communicate to me that it is hooked up. And I'm going to wait for a little while before we continue on. So we're at 56%. I need another person to continue on. So let me know if once this is complete. So again, we are at 56%. 63, perfect. All right. So 69, great, awesome. Now I'm going to lower your hands and go on to the next. So again, we're taking a more close-up approach look at it, and we're going to take a red wire. Remember, red is the 5 volts are hot, and that is coming from out of the 5 volt power to the outer left, and make sure that it goes red, white, yellow, black, or red, color A, color B, and black. Again, make sure those holes make sure those columns are next to each other, because when we set the ultrasonic sensor in there, you have to make sure they are lined up, or you could, at worst, fry something. So, not a good thing. Again, let me hook up mine as we continue on taking a look at it. So I have 12 in here, going into and 13. So when you're done, let me see a raise of hands. Again, when you are done hooking this up, let me see a raise of hands. So I know that everyone is hooked up. 63%, perfect. Now, the next slide. This is what I did was, you want to put the pins in here before you hook this up. You want to make sure that you can read on the ultrasonic sensor, if the two eyes are looking at you, that you have, starting from the left to the right, you have VCC, which stands for the voltage in, and it's a 5 volt, takes 5 volts to power this. The next is your trigger, and that sends the signal, the ultrasound out. And then you also have an echo, which receives the ultrasound. And then you have ground, and you want to make sure that all lines up with, on your breadboard, with ground matching ground, echo matching echo, trigger match the trig matches the trig pin, and VCC matches the 5 volts in, and put it in that way. So again, it doesn't look like this, but I did this to make sure that all of your pins are lining up. Again, it looks more like this, and that's how it should look, but on fritzing, it looks like this, which is a very elegant way to look at it. So again, I'm going to lower your hands, and once this is complete, let me see a raise of hands once this is complete. My ultrasonic isn't orientated like that, is it? Okay, let's see. So Ari, let's have a question. Ari, you're unmuted on my end. Please unmute you and ask that question. Ari, how you doing?
Well, you said to raise our hands when we were done.
Oh, you also had a question.
A question? No, I was just, you showed us what it looked like.
Oh, okay, perfect. Awesome. Thank you. So again, once this is done, make sure the ground lines up to the ground and all the rest line up the way they should. Again, I have 44% of you. I'm not going on until we have 60%. Now make sure you raise your hands if you are done. Should we upload the code? Yes, that is coming. So, not yet though. That is coming, Jacob. If you want to, you're more than welcome to. And if there's any errors, we will combat that as we continue on. Again, we have 50% of you. So again, raise your hand if you have this hooked up. %56 now. Good. Getting closer. All right. Again, when you have this hooked up, make sure you raise your hand. Don't do anything else yet. All right, let's go ahead. And here is another picture that I made that you can also look at it too. Sorry about that. That was my phone. So let's continue on and look at this again and continue on down. Now, I'm going to lower your hands, and if there's any questions at this point, raise your hands if you have any questions at this point. Again, raise your hands if you have any questions at this point. All right, perfect. Someone has a question. Jacob. Jacob, hi, how are you?
Pretty good, except for I have a error.
Okay. What is your error?
Well, I'm looking for it at the moment. I fixed one error, but I have another. It says in function void loop.
Okay.
And then I have another that says expected a gate. And I think I have all my little curly hue, whatchamacallits, parentheses.
All right. Keep searching for it. This is kind of the trick to, I mean, I think you have some programming experience from what I understand. So, the trick is to kind of to look for it. Now, it's in the void loop somewhere. Now, do you have an extra one in there, an extra semicolon or something? That may be part of it too, but keep looking for it. I'm going to mute you and continue on. Yichin. Yichin, hi.
Hello?
Yichin?
Oh, hello?
Yes, Yichin.
So basically what my question is, I just saw that in that diagram that the ultrasonic seems to be right over the breadboard, or is it supposed to actually be outside the breadboard?
No, it's right. Those 4 pins line up in the breadboard. So if you look, see the screen? Do you see my screen? All right.
It looks like it's like vertical or something.
This is vertical. It should be vertical like that. It should show up exactly like how I'm looking at it now, except I have a blue and white wire in here. And that's what I said. It's a little different.
So you basically do connect. So you do connect the ultrasonic onto the breadboard?
Yes.
Okay.
Yes. Good question, Ichin. Ichin brings up. Keep going.
Yeah, I don't know. I don't even know how to do it. Oh gosh.
You know how to do it. You'll be all right. So basically, I'm gonna mute you and I'm gonna explain it, and then we'll get back to you if you still have a question. All right, Yichin?
Okay.
So Yichin brought up a good point. You have 4 pins on your ultrasonic sensor. Now those 4 pins go into 4 pins in and on your breadboard. The last one, last row in this case, right here, you should plug it in. Again, it doesn't look like this. This is just to show you on top of everything. It should look like this. And if you notice, there's the header pins right on the back of the right behind the 2 eye-looking things, the trigger and the echo, and those go right. Those pins are lined up exactly like it is on, or the spacing is lined up exactly how it is on your breadboard. And I don't mean exactly. There's some give or take. I don't even like to use that word, but there is. It does line up with a snug fit, but yes, you do have to go in there. All right, the code works now. Yeechin, yay, I actually got it now. Awesome. Now I'm going to see if there's any, scroll any more. Make sure you have, if you have any questions, Yeechin, I'm going to unmute you and make sure you got it. Yeechin. Hello, Yeechin.
Okay.
Get it working?
All right. So
Awesome.
yeah, I think I got it. You have to actually push. Yeah, you push those pins inside the
Yes, absolutely.
breadboard.
Yes, absolutely. Thank you, Yeechin, for helping me clarify that. Now what we can do is, well, if you have any, connect, again, you sometimes went ahead of me, connect the Arduino to the Raspberry Pi using the USB-B cable and upload and run the program here. What I'm going to do is I'm going to run it from here. And I didn't even pick a serial port, so I messed, and that is correct. And uploading, and done uploading. So again, I'm live here, but don't want to be live yet. So when, oh, Beechin, I think that was the last question. If I'm going to lower your hand and make sure you connect it and then run it, and then raise your hand once you are hit run and it's working, or raise your hand if it's not working. How about that? Or raise your hand if you have a question. Corey, where is it reading the distance from? In the front of the actuator or the board it's on? Good question. Good question. Now in the next slide, what happened is, here's some errors that came up, and click, what you do now is you can collect, once that is complete, you click on here for the serial monitor, and mine is out of range, 917 meters, 15, and that's actually, it's pointing to me if you can see it, so I am this far away, 17 meters away. So again, what I'm going to do is I'm going to spit it out, turn it 90 degrees from me, and it is now out of range. One thing that you can do, which is cool, is you can put a box in front of it like that and start to calibrate it. So again, now if you notice that in front of what I did was I had the ultrasonic sensor, and I had a ruler, or what I like to call a scale, because rulers are actually from another time. And anyway, so we have the scale, and it's a linear scale, and we can put a box in front of it or something. You put your hand in front of it, and to actually use. And again, if I put my hand in front of it now and go with the serial monitor, it notice that I'm 13 centimeters away. And if I close, and if I decrease the size, now I'm centimeters out of it. If I decrease it even more, sometimes it bounces off, and it doesn't do well with if I start moving my hand. So again, it's kind of tricking it a little bit. So what you can do, it's kind of running out of class again, is do this, or one question that I had, we had it in centimeters. So now I'm going to ask you to, where in the code would I look at this, and I change the code to convert this output into inches. So again, there's only 4 minutes left, so this is kind of a game we can start to play. And I'm going to lower all your hands now. And if you have I already found a way to confuse it. Good job, Jacob. Wait, I need help, Ari. In a second, I'll get to you. So let's see, how would I convert this to inches? Now, when you guys are thinking about this, I'm gonna ask Ari, unmute Ari and see if he has any questions. Ari, you're unmuted.
Yeah, it says it doesn't have a println component, and I know I spelled it right.
You know you spelled it right. That's the programmer's guide to maybe. So what you can do is, and it happens to all of us, is look on where you have, see where I highlight right here?
Is it not capitalized? The L?
No, the L is not capitalized.
That could explain it.
Exactly. So great job. So again, we kind of you got to make sure that everything is written as is. And remember, the L and the I, the lowercase L and the uppercase I look very similar. So be very cautious of that. Again, I'm going to lower all your hands. And Jeremiah brought up one, and his says distance equals duration divided by 2. So right here, if in the distance you would have a duration here and divide that by 2.54. Jeremiah, you are correct, which is awesome. So also the make sure someone said, Mr. Holt suggested that make sure your pulse in this is an I, not a lowercase l. That's another way to look for it. No need for me to confuse it. Even if I put a small box in front of it, it says 14 centimeters, even though the box is much closer. All right, that may be a thing with your sensor, or make sure your code right here for distance is correct. Again, if you did not correct it, if it's not put in exactly like it is, the way I explained it, it could be changed a little bit. Awesome, guys. Nice job. Corey, I think you had a question. Corey, hi. How you doing?
Hi.
Oh, you had a question?
Well, I didn't hear you.
You didn't hear me? Or who didn't hear me?
Bad. So to change to inches, you would tweak the speed of sound, which I'm already attempting to tweak thanks to a bit of error.
That's all right. That's good. Tweak it some more. That's awesome. I know that I think Jeremiah said you can divide that right here where it says when you're actually giving distance variables, you can actually divide that by 2.54, which is 2.54 centimeters is equal to 1 inch. So, or you can convert this 29.1 to something as the rate of speed of sound in inches per second, or I think it's per microsecond. I'm not sure how we converted that. So it's actually the pace, I remember. So again, it is 6:30. Again, some things we can think about to do it. What are some applications we can use? And I'll be asking you this on Wednesday, and also ways to trick the sensor. So keep that in mind. To kind of those two other things. And if you do not have any questions or got everything in your packet, and let me go back to the packet that you should have, I'm going to end class now. So I had fun. It is now 6:31. I went over a minute, and class is ended. Looking forward to seeing you on Wednesday when we talk about servos. Servos it is. So, and anyone, I think Austin, stay on the line a few minutes to let everybody off, and then we can continue on. Right now, I'm going to mute it for everybody to kind of get off offline. Then we can talk about what we need to do to get you the stuff.